So now that we know how to find an inverse, we do need to verify that two functions are inverses. So this will actually apply what we learned in section 1.4, which was composition. So to verify two things are inverses, you'd be given two functions, f of x and g of x, and you'd have to prove that f of g of x, so putting that second equation into the first equation, is equal to g of f of x. So putting that first equation, taking the second one, putting it in the first one, taking the first one, putting it in the second one, and when you do that, you will get x for both of them. So we're going to start off with two functions for this first example here on verifying, where we have f of x is going to be equal to the cube root of negative x minus 3, and then g of x is going to be equal to the negative x cubed minus 3. And so we're going to have to do two compositions, one where g goes into f and one where f goes into g. If they both are equal to x, we've proven that these two are inverses of each other. So we're going to skip past the step we just did where we found the inverse. I'm telling you that this is the inverse, but now we need to prove it or verify that. So f of g of x means that we're going to start with that f function. This is a composition, so we're going to start with that f function on the outside, and we're going to put the g function on the inside. So if I start with the cube root of minus x, throw some parentheses up here, minus 3, this will also be under the square root. Instead of x here, I'm going to write g. My g function is negative x cubed minus 3. And now I need to simplify. Now I can only simplify one thing at a time, and I need to rewrite my equation as I go. Your answer, we know what it's going to be, because if we prove it right, it should be x. But the issue here is not, can I cross something out and say, yeah, it's equal to x, but that I can show what simplifies so I can get it down to x. So all of the work ends up being your answer. So for this problem in particular, the first thing that cancels is this negative, I have to distribute this negative to both things in parentheses. So nothing's even going to cancel to start. Negative times a negative is a positive x cubed plus 3 minus 3. So I've distributed this negative to both of these terms. Now I can cancel these 3's, so I have the cube root of x cubed, which gives me x. So now I've proven that f of g of x equals x, and now I need to do that another time and solve for g of f of x. So when I do that, the g function will be on the outside. And so we're going to start with negative quantity cubed minus 3. And in here, in this parentheses, will go my f function, which was the cube root of negative x minus 3. Of negative x minus 3. And so here, the first thing that I can do here is I'm actually going to cancel that cube root and that cubic. So I have negative x minus 3 minus 3. Now I will distribute that negative sign. So I have x plus 3 minus 3, which leaves me with just x. So now I've proven that both f of g of x and g of f of x are both equal to x. So yes, these are inverses. Now the second example that I'm going to do today involves two rational functions. We're going to prove that these two are inverses of each other. So I need to start off with f of g of x. So I'm going to take my first function, f, write it down, and then I have a big thing of parentheses here. Then I need a minus 2 and then a plus 1. So in this parentheses is going to be my g function, which I copied from right here and put in these parentheses. And I'm going to try to simplify this one step at a time. So the first thing I see is this crazy denominator. I'm going to deal with that. I'm going to cancel these 2's. 2 plus 2 minus 2 goes away. So I have 3 over x minus 1 plus 1. So now I have a fraction over a fraction, or something that I can try to simplify. So if I start with the numerator, which is just 3 over 1, if I think of just the numerator, times the reciprocal, x minus 1 over 3, because when you're dividing by fractions, you really multiply by the reciprocal, so I flipped that fraction, and I've got this plus 1 still at the end. So I need to deal with this big fraction that turned into two fractions being multiplied together. Now the 3's will cancel, leaving me with x minus 1 plus 1, which just simplifies to x. So I've proven that f of g of x is equal to x. Now I need to do this a second time with g on the outside, g of f of x. I'm putting f on the inside. So when I do this, I start with my g function, which is 3 over, big parentheses, minus 1 plus 2. Inside these parentheses is the f function. So I'm going to put the f function. F function is 3 over x minus 2 plus 1. Again, first thing that cancels is that denominator, is that plus and minus 1. So then I have 3 over x minus 2, and then a plus 2. Again, I have this big fraction that I need to simplify. A fraction divided by a fraction is just like multiplying by the reciprocal. So I have 3 over 1 times x minus 2 over 3, and the 3's will cancel. Let me finish the rest of my problem here. And so I have x minus 2 plus 2. 2's cancel, leaving me with just x. So again, I've proven that g of f of x and f of g of x are equal to x. Okay, so this next problem that I'm going to start off with, I'm actually going to give you f of x, and then I'm going to find the inverse. So f of x is going to be 2x squared plus 1, and I need to find the inverse. So first off, just to review, finding the inverse means we're going to change that notation into y, 2x squared plus 1, then swap x and y, equals 2y squared plus 1, and then I solve for y. So I'll subtract 1, x minus 1 gives me 2y squared, divide by 2, and I get x minus 1 over 2 is equal to y squared. Finally, I need to get y by itself, so the inverse of squaring something is square rooting something. So I square root both, and I get the f inverse of x is equal to the square root of x minus 1 over 2. So now I'm going to use this function. I've created the inverse, but I need to prove that they're inverses of each other. So I'm going to use the two compositions, f of f inverse and f inverse of f of x, which just means that I'm going to take the original function and put in its inverse in a composition. Then I'm going to take the new one, that inverse, and put in the original and do that composition. And when they both equal x, I will have proven that they're inverses of each other. So for this first one here, I'm going to start off with 2 on the outside, and then my parentheses of the square root of x minus 1 over 2 quantity squared plus 1. So I have the 2x squared plus 1, and in x's place is my inverse function. So I can simplify this. The first thing I can simplify is the square root and the square root can cancel. So then I have 2 times x minus 1 over 2 plus 1. The 2's will cancel next, leaving me with x minus 1 plus 1, which just gives me x. So I've proven that one way. Now I need to do it the other way with the inverse on the outside and the original equation on the inside. So I'm going to start off with my inverse equation here. So this was my first way, this is my second way. I'm going to write my big square root of parentheses minus 1 over 2. And inside those parentheses is going to be my original equation of 2x squared plus 1. 2x squared plus 1. So now I'm going to simplify these one thing at a time. The first thing that cancels is actually going to be the negative positive 1. The cool thing about these equations is that most of the time, I'm going to go ahead and say 90% of the time, the first thing that cancels in your second composition is the last thing you canceled in the previous composition. It's really cool how that works out. There are a few cases when that doesn't work out, but in this case, it does work out. Like I said, 90% of the time it does. I'll show you one in a few days that will not be that case, but this one is that way. And then you can kind of go backwards. Oh look, the 2's was the last thing we canceled, so then the 2's will be the next thing we cancel here. And in this one, we'll have the square root of x squared, which simplifies to x. You'll notice that the x squared and the square root was the first thing to cancel in the previous one, and that's the last one on this one. So now we've proven that these two are inverses of each other. Alright, so the last problem for today, we're going to try to prove that these two functions are inverses. We have 5x minus 10 and 6 plus 3x all over 2. And so that means we need to attempt to do f of g of x for starters. So we would take 5 parentheses minus 10, and then I'll put my g function inside, 6 plus 3x over 2. Now, I don't see that the 5 canceling with the 2 is going to happen, so I'm going to try to distribute and see if that'll help. So I get 30 plus 15x over 2 minus 10. And again, that doesn't seem to be canceling anything. If that is the case, then these are not inverses. Not f of x and g of x are not inverses. The only way they can be inverses is if you end up with the solution to their composition being x. That's the only way.